Welcome to Physics World. Every day in the morning, you hear so many sounds. Some sounds are pleasant to you. Some sounds are noiseful to you. But anyway, even the pleasant or noise, you are hearing the sound. And you produce sound also while you speak, while you talk to a person, while you move a what do you say that a heavy body on the surface because of friction. If you take a chalk piece and if you write something on the board with a chalk piece, it produces sound. When you switch on the audio player, it produces sound. TV produces sound. So sound is everywhere. So you have to learn how to listen to sound, how to control the sound. First point. Second thing, how do we communicate with each other? You may know, you may have heard, or you may learn in English classes about two types of communication: verbal communication and non-verbal communication. And the difference is, verbal means by speaking, unwritten communication, oral communication, how at present how I am communicating to you. Non-verbal, without talking, written, by writing, by using some signs, some symbols. If you communicate to other person, it's called non-verbal communication. But 80% all we do verbal communication only, means we speak and we talk, and there we produce sound. Now here it is very, very important that what is the physics behind sound? How can we produce different types of sounds? How can we control the sound? And how the human being, how we are producing sound? Do you have any other machine inside which is producing sound to us? Or do you have any other machine in your body which takes the sound and makes us to understand? So all these things you need to understand. So that's why, so today's chapter is sound. So if you see, if you go to the open theaters, you can see big loudspeaker and it produces a very large sound, so that wherever you are there in 360 degrees, you can hear the sound. Similarly, using mics, when you speak, it produces sound. At present, I am using caller mic, it also producing sound, and you are hearing to me. So all these examples tells you that sound we are producing. And the question comes that what is sound? Sound is an energy content. Yes, it's energy content. How? The kinetic energy is energy. How? The potential energy is energy. Solar energy is energy. Sound is also an energy. Just like light is an energy. When you speak something at one point and the sound is traveled to some distance, say you started speaking here, okay, you started speaking and the sound travels to a point B where there is a person who is receiving the sound. Generally, if you want to draw a diagram, we draw the diagram like this. The sound is going from one point to the other point in this direction. What is symbols called? This semicircles are called. It is called waveform. Waveform. Initially, I have informed you that sound is an energy. It is an energy. Now I am saying that sound is a waveform. What is this? Means sound is energy as well as wave? Yes, you are correct. Sound is energy and sound is wave. How? See, I will tell you how it is possible. Scientists wanted to explain to all people that how the sound looks, because you can't see the sound. You can just experience the sound. They understand that with the sound you can break a glass. With the sound you can move a body. How it is possible? A sound can break a glass? A sound can move a body? It is only possible if the sound has energy. And many examples in the movies in your TV channels, you have seen that the sound is breaking the glass. And that simple example tells you that sound is energy content. So sound is energy. Now the question comes, how do you show that energy on the board? How do you show that? How do you experience that energy? So that's why scientists made a pictorial representation. And that pictorial representation of energy is called waveform. So wave is the pictorial representation of energy. So it is pictorial, means picture. Pictorial representation of energy. So you understand. So sound is wave because a pictorial representation of energy. But what wave we can use? In mathematics, we have so many types of waves. But based on the changes in the energy, the physicists understood that wave is in sinusoidal form. Sinusoidal form. Sinusoidal form means it is either this way, or it is in this way. If you see, both waves look same, but the starting is different. Here the wave started at the origin, O. Here the wave doesn't start at the origin, it started at some fixed value. So either the way you can show the pictorial representation of the energy, which is you can show the sound. So how can we show? Now we're going to discuss. Before going to discuss about the properties and the characteristics of sound, as I mentioned you earlier, sound is a wave. So let us discuss about some fundamentals of wave. Then we go to sound. See here, as I mentioned you, wave is pictorial representation of energy. Now this wave is classified into many types. Mechanical wave, electromagnetic wave, matter wave, many classifications are there. But here our subject is limited to mechanical and electromagnetic, and we are not touching electromagnetic because this is not in sound. So coming to mechanical wave. Mechanical wave means the wave is produced because of mechanical force. That mechanical force is applied because of your muscular force, some machinery force. So based on the mechanical force, the mechanical energy is produced, and because of mechanical energy you have mechanical wave. And this mechanical wave again classified into two types: longitudinal wave and transverse wave. So this is our point of discussion: longitudinal wave and transverse waves. Now the question is, what is longitudinal and what is transverse? See here, longitudinal wave. If you see on the board, I had drawn some dots, some lines. Think that this line is air medium. So air medium, or any gaseous medium you can take. For example, I have taken air medium. Air medium consists of many particles, because medium is nothing but consists of particles. So as this air medium, you have air particles everywhere. So in that I have chosen 4 air particles, A, B, C, D. 4 air particles I have chosen. Now, when some wave comes through the air, see what happens. So this is how the wave comes. Seeing here is the wave is going in this direction towards right side. When the wave goes towards right side, actually what happens, while the wave enters into the air medium, this particle do not stay at rest state. They starts vibrating. Vibrating means to and fro motion. How they vibrate? When the wave enters into the medium like air, the particles will vibrate like this, horizontal. See, I'm keeping 2 arrows, left and right arrow. This means if this marker is a particle A, then the particle A vibrates like this. Like this. It vibrates like this. Okay. Now particle B also vibrates. But how particle B vibrates? When particle A vibrates, this particle A at one point of time, it touches particle B. Immediately particle B starts vibrating. When the particle B starts vibrating, at one point of time it touches C, and particle C also starts vibrating. In this way, all the particles vibrate horizontally. This is a horizontal line. You know in mathematics, this is horizontal, this is vertical. So horizontally. So particles are vibrating horizontally. Wave is also going horizontally. So I can say longitudinal wave is the wave when the particles vibrates along the direction of the wave. So particles are vibrating along the direction of the wave is what called longitudinal wave. Understand? Now examples of longitudinal wave are sound is longitudinal wave. Next, spring, waves in spring is also longitudinal. And you can produce water waves, also longitudinal. So sound, springs, water are longitudinal waves.